Hello, everyone. Come on in. Welcome back to a new semester. COVID-free since '83.
Good evening.
How are you? Glad to see
Doing
people.
well. How about yourself?
Not too bad. I saw most of you answer my email yesterday, so that was cool. I'm not going to be able to change anything, so it's going to stay like it is. It was just kind of a bummer. I made the correction or told my the person in charge of our office that the time was wrong, and they never went back and changed it. And I didn't notice it was still there until last night when I started to go over setting up your course and everything. So it's kind of a bummer because I saw that I only had 19 enrolled last semester. I think we ended up having like 38 enrolled in this time slot. So no biggie. We've got 19. That's enough to let go. It's just a kind of upsetting. I would have liked to have had even more. I want to help as many students get whatever classes they need as well as I can. If you guys, I'm not exactly sure. I don't think it records your name. I didn't recall seeing it in any of the YouTube videos I made last semester, but if y'all want to, you can certainly just keep your first name and signing in just in case y'all are in the witness protection program or you're hiding from, Guido or whatever. That's a generic name I use for a mafia person. It's probably anti-Italian, so I apologize for that. But anyways, just I want y'all to be safe. So if y'all have any problem with people that might be looking for you or people you're trying to hide from, just feel free to just use your first name on here. It logs in with whatever name that is, and I can tell from that. And I don't, as far as this class goes, I don't care too much about logins, about attendance. The only thing I do is I look for people not attending for, multiple days in a row, and then I'm supposed to drop them. So other than that, there's no big deal about this. Does anyone have any questions? I'm going to go over the syllabus in a second, but does anyone have any questions before we get started? All right, well, there is a package that this bookstore sells. It's a package that includes the textbook, which you guys probably already have because you're in 242, but just in case, I want to make sure everybody knows there is a package. Like if you've taken 241 somewhere else and you're taking 242, probably the cheapest package they have is one where you buy an ebook. The next cheapest is where you buy ebook, but also it comes with like a binder ready book. Oh, thank you. Yes, it's still 445. Thanks for answering that, Georgie. And it'll have to stay that way because I had several people that just couldn't change it now. So that is the cheapest route, is just get the ebook with the mastering access and all that stuff. So that's probably the cheapest way. If you like to have a physical copy of the textbook, to be honest with you, if you find a third edition, that'd be plenty good. They're not that far off, the third edition, fourth edition, but the book's getting ready to go into the fifth edition. So this book's not going to be very valuable after probably next semester. So, and actually it might not even be valuable anymore. A lot of schools have already switched to the next edition of Giancolli's fifth edition or whatever. So let me get started on the course material. First, I'm going to share my screen and show you our course syllabus. It's an amazing day. This is for the first time in a long time. I actually had my syllabus done before class. Is that amazing or what? I don't know. I've become a teacher. It's crazy. As you all know, it normally that you get to look at, and maybe it has the official syllabus. If you ever forget that, one thing I want to point out to you guys: this stuff the college requires me to put in there, so you can always get that to help get Canvas support or Zoom support, or if you want to see the academic calendar, stuff like that. So that's pretty generic, but this stuff is specifically to my course. So it's, of course, obviously very important for you guys to make sure you watch this extremely interesting video about course syllabi, and then you can read my course syllabus here. So that's what I'm going to pull up right now. Still got some people coming in, so I'll click on them as we go. All right, so what we're looking at currently is an inability of my browser to open this page very quickly. We kill some of this other crap I got going on in the background. That might help. Kill that. I'll leave that. Okay, so this should be it. Yes, it says class section N05B. I want to point out that to you guys because what I need you to start all of your emails. If you send me an email, and my email address is listed down below, if you send me an email, it should start with 242 space N05B. That's what I look for to make sure I don't miss students' emails. And I get so many emails, I still will miss some, even if you do it right, but you're going to get no chance of me noticing it if you don't have 242 space N05B as the beginning of every subject line. That usually means you need not try to email me from Canvas because Canvas does some weird stuff. So I would advise not emailing me from Canvas. Just use your TCC account, not your Canvas account. Here's my contact information. So what I'm giving you here is my personal cell phone number. And if you ever send me a email and you don't get a response from me within one working day, so like if it's Friday, if you don't get a response, if you send an email on Friday and you don't get a response from me by Monday, then you need to go ahead and send me a text. Okay. However, if it's Monday, you send me an email and you don't get a response by sometime Tuesday, then you can send me a text. That's what I'm using this for. Just make sure you identify yourself, both your first and last name, as well as what class you're in. So 242 N05B. Okay, that's my office phone number that has a time-stamped ability to leave a voicemail. I never answer it. I especially didn't answer it during the pandemic, but I very seldom answer it because even if I'm at school, I'm usually working in the production studio or in the lab or in the planetarium or some other places. So it's very hard for me to ever answer that phone. But if you have something come up where you're going to miss a test, that would be the place where you'd want to leave the voicemail to me and let me know, hey, this is such and such at such and such a time. My car broke down or I've been in a small accident. That's what that's good for. Here's my office hours. Again, assuming we're getting ready to go back, ever get to go back on campus. So far, we are meeting with your class. You're going to meet basically at 4:45 every day by online because that's just your online class. But if we are allowed back to school, I'll be having office hours in my office at that time. And of course, you can always talk to me right after class. In this class, especially, you can talk to me right after class, and we can set up appointments through Zoom as well for you internet students. There's my email, wyounger@tcc.edu. Again, if you don't get a response within one school day, then text me. Here's the generic stuff that they force us to put in. Prerequisites, that sort of stuff. Here's the safety warning that I tell you guys, and just as a general rule, I would never eat in a lab. I would never drink and I'd never eat in a lab. Even our lab, which is pretty innocuous, we use radioactive stuff and lead and all sorts of stuff that are really poisonous and toxic to people. So it's the kind of thing that could kill you. Biology is probably even worse. Not only do they have poisons, they have biohazards and stuff like that. For your own safety and for the longevity of our lab equipment, please refrain from touching any equipment before you've been taught how to use it. And once you've been taught, only do the things that we suggest you do. In other words, the things we've taught you to do. Don't go experimenting with our experimental equipment or it will be broken. And some labs will require us to use gloves, goggles, aprons, all sorts of stuff like that. When they're at your workstation, when you get to the lab, then you're, again, assuming you're face-to-face lab, when they're at your workstation at the lab, then you are expected to wear those. So just keep that in mind. This was so important, I decided to put it in twice. Actually, no, it's just a cut and pasting error, but it is important, especially for you guys, since you are an internet class. You need to have reliable access to a computer with internet service. We give you Zoom through here. Of course, we also give you, as a student of TCC, you get a site license for Microsoft, the entire Office suite. So you can have Microsoft Office, Microsoft Mail, or excuse me, Microsoft Word, Microsoft Excel, all that good stuff, and PowerPoint as well. This is that package I told you about. This is the ISBN. Now, other booksellers will sell you something, but it won't be this exact ISBN, and that'll end up with you not having access to, say, mastering physics, which is sort of important. That's our whole homework set up. Okay, I do ask you to have the textbook, which includes the modern physics, and it can be just an electronic textbook. An ebook is fine. If, again, the cheapest way to get a physical textbook, just if you like reading an actual thing you can hold, then by all means get a third edition. That would be fine. You have to have access to modified mastering, which comes with that package above. You need a ruler, a centimeter scale ruler, a protractor, not any amateur tractors here. Dad jokes 101. Pen, pencil, eraser, graph paper would be helpful. In other words, if you don't have graph paper, there's going to be some time where I'm going to ask you to use Excel to make your own dang graph paper. So you might as well get a little bit of graph paper. And you have to have a scientific calculator that can't be on your phone. Okay. You have to have one separate from your phone because we're going to take tests and you're not allowed to have your phone during those tests. Here's a COVID related caveat. Caveat is just a fancy word for rule. I don't even know why I wrote caveat up there, but maybe y'all remember caveat emptor. That's, I'm partly here to teach you vocabulary. So in the event the school switches to online learning only, then students will either need a webcam and respond to lockdown browser. Obviously, this is true for you guys, period, because y'all are our internet. So yeah, you do need respond to lockdown browser. If you have some problem where that doesn't work, sometimes people with Chromebooks have had some difficulties. If that's the case, then you're going to have to take your midterm and final at the testing center for this class. So just be aware of that. Additionally, once the school goes to online learning only, then not attending lecture and not logging into Canvas may be counted as absences. So that's really what I use absences for anyways, but I don't really take off any points or anything for you being absent. It's just a matter of I have to keep track of when your last date of attendance is for federal purposes. So keep that in mind, please. This tells basically all we're covering. It's not that critical. You'll see by chapter numbers what we're going to cover. The types of assignments and assessments we have is basically every week we're going to cover a whole chapter. Okay, and then sometimes you'll cover 2 chapters or a chapter and a half in a week or something like that. So just keep that in mind. For instance, chapter 22 is really short, and we normally cover that in a single day. Okay, but you will have, because of that, occasionally one day we'll have 2 or even 3 homework assignments due on that same day. There's also some chapters that have 2 homework problem sets for that one chapter alone. In that case, you'll obviously have 2 due on that same day. But the way this course works is I've set it up where your conceptual questions will be due Sunday. So this week we started on Monday, obviously. So your concept questions for chapter 21 will be due Sunday, and your homework problems for chapter 21, which are the ones where you're actually solving problems using mathematics and stuff like that, and vectors, that'll be on Tuesday at 11:59 p.m. I really should write 11:59, not 11:55, but you get the point. Okay, so the conceptual homeworks will always be due Sunday. The problem homework, where you're actually solving physical problems, mathematical problems, and that sort of thing, they're always due at 11:59 p.m. on Tuesday. So make sure you keep up with that, and just expect you to have to do those every Tuesday and every Sunday. That'd be your best bet. That way you don't miss any. I'm not changing any dates this semester. I know I've always done that in the past, and I thought I was being nice by doing so, but it's really put a amount of stress on me that's kind of hard to deal with. So I can't do that. I'm setting the dates. They've already been set. In fact, they're all saved in my lab and mastering. You can see them immediately if you want. Those due dates are hard and fast, and you lose points for each day that you're late on them. So if you're 1 second late, you turn it in at midnight instead of 11:59 p.m., then it's automatically missing a whole day. And then if you go past midnight the next day, you're going to get deducted twice as many points because it's increasing by the day. So that's the main things. You're going to have a concept questions as well as problems to solve for each chapter, and they're always due on Sunday and Tuesday. They're also going to be about every 2 weeks. We'll have a chapter that covers mainly 2 chapters, but they're always comprehensive, and they're going to be completely online, open notes, open book, open internet. You're allowed to do Google searches. The only thing you're not allowed to do is to read a document or a website or anything else made after the date after the time that I post the actual test online. That's for obvious reasons. I just don't want someone to take the test and then report or make a website or whatever saying exactly what was on that test, and then you make use of that to actually take your test. That would be obviously cheating. So that's the only rule. You're just not allowed to do that. It's kind of a pain to do that. So chances are you're not going to do that anyways. but I do, just because I know when I had take-home tests, I know a lot of students cheated and I didn't like it. So I give you all the freedom you want. You can use your book, you can use your notes, you can use someone else's notes as long as they weren't made after the actual test was released online. You can use any other textbooks you want, and you can even Google for answers. Okay, I will advise you that Chegg has a lot of mistakes, though it does exist, and I encourage you to use that if you can. But just be advised, they do have mistakes, and I don't always allow those mistakes into my set. So you're sometimes going to get it wrong, even though you got what Chegg said. So just be aware of that. There's also going to be a midterm and a final, both of which are comprehensive. There will be a comprehensive midterm, and somehow the word final exam disappeared from this line of my syllabus. This is supposed to read, there will be a comprehensive midterm and a comprehensive final exam. No cell phones can be within reach on those tests. Of course, I know sometimes people are doing duty or whatever with the military, so I sometimes make special arrangements on that. You need to let me know well in advance so I can see what I can do for you if that's the case. But generally, no cell phones, nothing capable of accessing the internet is allowed other than the computer that you've got using a lockdown browser. Okay. You only be allowed to have verified blank paper and equation sheets. I, in fact, put the equation sheets online already. So in that area where you found the syllabus, you also see a copy of 241 and 242 equations that I allow. As the semester progresses, I'll write some equations that aren't in the book, or even use one that is in the book and say, you're allowed to use this even though it's not numbered. So each time you hear me say that, you need to write that down and say, put this on my cheat sheet. Okay. So that's up to you. I'm not going to have a memory of that as it goes. I'm just going to tell you in real time. And if you don't hear me, you're not paying attention, that's going to be on you. Okay. Yeah, that's about it. And that's what I'm saying by take notes, to make sure you pay attention. And if you hear that I allow you to use this on the test, then by all means, you need to make a big box around it with red pen or whatever. You are allowed a pencil, an eraser, and a scientific calculator. The final exam is actually going to be like a 2-hour and 10-minute interval. So I'm allowing you up to 2 hours and 10 minutes. You can do that by either showing up early or staying late on that particular day, which I listed as 4/27. So make sure you can make it on that date by either coming at least 45 minutes early or staying at least 45 minutes late. If you find that that's not a possibility because you have some conflict with another class or something like that, again, you have to find. Now, coming to class means something different for us because we're internet. So just be advised, what I mean by that is you need to be on lockdown browser starting 45 minutes early or finishing 45 minutes late, but you're only going to get 2 hours and 10 minutes. In fact, if you start late, in other words, you don't start at 4:45, say you start at 5 o'clock, then you're not going to be able to fit in the 2 hours and 10 minutes, and that's going to be on you. So make sure you don't start late, whatever you do. If you have some problem, some conflict that doesn't let you do that, you need to let me know about a week in advance so we can work out something. It might be that I allow you to take it at a testing center. It might be that I allow you to take it a different day. I just had to make another test and that sort of thing. The real deal with the midterm and the final is generally I make one so everybody gets the same test. Obviously, if people are taking it at different times, and that kind of defeats the purpose of having everybody take the same test, because the student that takes it a day early might communicate what was on it to a student that takes it the right day. So just keep that in mind. That's what all this crap's about. Here's my actual calendar. I'm only showing the Monday, the Wednesday, and I'm actually showing what lab we're doing that week as well. That actually may change here and there, and actually it's not showing me that right column because I can't get there for some reason. Where'd it go? Wonder if I think it might have altered the format when I changed it in PDF, and it looks like it might have cut that third column off. I will have to repair this, and when I do so, yes, you notice it cut that whole thing off there, so that's a problem. But anyways, I'll refurbish that. It shows you the order of the labs we're doing. The very first one is a refresher on Excel. Spreadsheet review is what it's called. So that's what we'll be doing this week. You can see I'm doing chapter 21 is what I start today, and tomorrow and Wednesday it'll be done. Of course, we're off on Monday due to Martin Luther King Day. Then on the 19th, which is the Wednesday after Martin Luther King Day, we'll have chapter 22 started. But that's literally the only day I'll spend on it, because the remaining chapters 23 and 24 require me to use what's learned in 22 over and over again. So I don't mind doing it that short. Okay. Notice I have due dates for all the online tests. Those are written in stone. They'll become available at least a week in advance. Or let me say at least, let's say Wednesday before they're due on a Sunday or something like that. Okay. But the way these have got it set up the semester, it's usually due on the same day, but at 8 a.m. So your class meets on Monday, the 24th. Chapter 1 and 2 will be tested on online test 1, but you have to be done with all your attempts by 8 a.m. That's another thing. My online test, I give you at least 2 or 3 attempts. But each time you take it, it's a different set of questions. I also give you a practice test, which is generally made up of the same questions that the actual test is made up of. So you can see the progression. We just go in order: 21, 22, 23, 24, 25, 26, all the way up to 31. Then we jump back and catch chapter 17, which is sort of the beginning of thermodynamics and heat. And then after chapter 17, we go to 18 and then 19, and then we brush through chapter, then we brush through chapter 20. And then after that, we jump to quantum mechanics, which is 37, 38, and 39. So hopefully I've got all that right. Actually, I'm seeing, there's 31. Oh, it's more days. That's what it is. Whew. I wasn't seeing chapters 17, 18, and 19. I thought I'd copied the wrong one. So here's chapter 17. We start on 30th of March. I'm pretty confident I can cover that in a single day. We're now at an hour and 20 minutes instead of an hour and 15. That actually helps a little bit. Then chapter 18 will take 2 days, or we'll still have to use the beginning of that a little bit for 17. All the material's up online already on YouTube, so you can, whatever I don't cover, I don't mind. I'm going to keep this pace because you can cover it online. Then 19 is going to take a single day, as will 20. And I'm just briskly going over those areas. I'm not covering them in great detail. That's why they're only taking a day each. And then online test number 7 is due at 8 a.m. on 18th of April. You can write all these down. I'm not going to change these dates at all. You can also write all these down, the homework dates for my lab and mastering, because they're not going to change at all. And what I'm showing you here is 4/27 is the due date, or is the final exam day. That's the day you need to arrive early or stay late. As far as the grades go, I use a 10-point scale, but I state in advance that 89.5 is going to be rounded up to an A, 79.5 is going to be rounded up to a B. Here's where I'm actually kind. So I give you a 11-point scale for C and D, so you can get as low as a 68.5, still get a C, and still get as low as a 58.5 and still get a D. Here's the kicker, or another kicker. The tests, those online tests, are only going to count 10% of course grade, because I don't know who's taking them. I'm not trying to find out who's taking them. I don't know what resources you're using. In fact, I allow you to use any resources, but it's really easy to make this mistake of thinking you understand something, because you can do these tests really well and get really good grades because you're pretty good at looking up stuff. So I don't count it very much, partly for that. So just keep in mind, your goal is not to do well on those tests by whatever means. Your goal is to do well on those tests because you know the material. The homework activities, in fact, cost twice as much, and that's the actual physical problems that I told you about, there where you're going to have to solve problems and stuff. The conceptual homework is only worth 5% of that. Okay, but notice I do drop the lowest online test, and I drop the 2 lowest homework assignments as well. There's the ones that are really like chapter 21 HW. That would be the type of title I have. But here's where I warned you about the kicker. The midterm exam is going to count as 20% of the course grade, and your final exam is going to count as 25%. So those are the ones where you have to take without those extra resources, because your browser is going to be locked down. You're going to be filmed the whole time. If you're doing anything suspicious, we're going to probably count that as a 0 for your exam. So don't do stuff suspiciously. There's a whole process you go through when you first log in. It tells you to show your work area. They want you to be looking up so they can see your face and eyes more or less the whole time. But if you're doing a lot of this and it looks like you're working under the area where you can work, then that's going to be a red flag. So if you're using your calculator, for instance, you want to punch it like this, or at least lay it on the desk and have your camera set this way so you can see that you're just using your calculator. Okay. The lab course grade counts as 20%, and notice that adds up to well over 100. It adds up to 105, and the reason why is because at the end of the semester, I take the average of all your highest scores on each of the practice tests, and I average them and divide it by 20, and then that gives me the number of points that I'm just going to add to the end of your course grade. Okay. Now, if you don't take a particular practice test, then you get a 0 for that one. So that's going to be counted in that average. And as you can tell, we got I think I worked out 7 tests, or no, 8 practice tests. So if you just chose not to do one of the practice tests, you are automatically starting with a 1/8 decrease, which is 12.5. So that's 87.5% is the best you can get on your test average, your practice test average. So I'd take that 87.5 divided by 20, and that'd be the number of points you get added to your final course grade. So I do recommend you take the practice tests. That's why I put so much work into making them. And that's why I give you fairly short homework questions or homework assignments. Now, if you happen to be in one of my labs, this is my lab grading rule. It doesn't have any bearing on you if you're not in my lab. Your instructor will tell you what you want to do in their lab. But the way I work it is you get basically 100 if you miss one attendance. So I check the attendance when you come into my lab, whether it's online or not. I check your attendance. And then if you turn in the lab report the next week, I check the attendance again to get the other part of the attendance grade. You're allowed to miss one of each, or 2 of one, or 2 of the other. But beyond that, it starts counting down. So your lab attendance grade goes from 100 first to a 95, then to a 90, then to an 85, then to an 80, so on and so forth. So the rule is make sure you're there for the vast majority of the class. Sometimes people will log in and then leave, like when I put people in the breakout room. Yeah, that counts against you. That's going to count as an absence. I don't care if you stayed there 20 minutes, that's going to count as an absence. So you got to make sure you're there contributing to your lab group, if it's online especially. Okay. And then the other 50%, assuming everybody actively works like they're supposed to. Like sometimes I'll find there's 1 or 2 strong people in a lab group, and they're pretty much doing all the work, and the other people are sort of like jellyfish just floating on the current and copying down what they say. If I see that going on, then I'll give y'all a comprehensive lab final, and that will be really, really hard, and it usually makes people's grades go down. So I don't want to do that. I don't want to grade that stuff. I don't want to upset you guys with your grades. I want your lab grade to be a thing that can help you not only learn experimental technique, propagation of error, that stuff, but I want it to also be something where it can help your grade. So this is just the usual caveat where they're telling you some things can change, but I'm supposed to let you know. And also your syllabus, I can't change that after the drop date, the final drop date, where you, if you drop later than that, you get an F. So just be advised about that. And your syllabus is sort of the most important document of your course. I can't stress to you how important that is. I've seen students fail courses specifically because they didn't read or take the time to thoroughly understand their syllabus. I've also seen students completely manipulate the system because they knew their syllabus inside and out and get an A when they really probably should have got a C or a B. So make sure you try to do that. Maybe not manipulate the system, but if an instructor like me is stupid enough to make it manipulatable, then I deserve to get that until I learn better. So when an instructor sends an email that requires a reply, the reply should be come back within 1 weekday. So I give you examples like Monday, you should get a response sometime before midnight on Tuesday. However, if you send me one, or if I send you one Friday, Saturday, or Sunday, then you should reply to me by Monday. Of course, the same rule applies to you guys too. You're required to check your TCC email accounts on all Monday, Tuesdays, Wednesdays, Thursdays, Fridays. Okay. And you're also expected to log into Canvas for course every Tuesday, Thursday, and Sunday. Okay, so just make sure you do that. Those are things I can count as absences if I need to. So I'm just warning you that. Please do not email me from Canvas. I almost never get to see it, so don't do that. The dean asked us to make sure you guys know that when you have a problem with me, even if you think I'm being a jerk or I made some comment that was stupid or sexist or whatever, you tell me about that. Okay. I know that sounds really scary and it's counterintuitive, but they want you to contact me first. Okay. The instructor first. I've never been, actually, I was turned in once for that, but it was a complete misunderstanding. Somebody didn't hear what I said. But generally speaking, I'm not like that. I don't hold grudges by any stretch of the imagination. If my student tells me you said something that was really hurtful, I will bend over backwards and tell you, I'm so sorry. I did not mean to do that. I never meant to do anything like that to my students. So don't be afraid of me, but do take any issues you have. If you really thought that you were going to, suffer some consequences by telling me something I screwed up, then I don't mind if you go to them first, but really they want you to go to me first. Okay. So anyways, attendance policy. All students are expected to be present. I tell you this, I had a lot of students that just sort of showed up and then left, or just showed up and then started playing on the game system or whatever while I was in class. Those students do not do well. This course is tough. And my particular version of this course is particularly tough because I teach you vector calculus. You're going to do stuff that you don't, if you're lucky and you went to, say, MIT or Caltech or something like that, where they expect you to have calculus when you get there. But for those poor, English majors or whatever that ended up at somewhere like that, they're expected to already have calculus too. If they don't, they're going to have to take calculus. But in their third semester of their calculus course, they would actually cover stuff like line integrals, surface integrals, divergence curls, Jacobians, all this cool stuff. And that's what we do in vector calculus. I teach you that here. Okay. And it's very normal to learn your math from your physics instructor or your engineering instructor. So just be prepared. That is a very normal thing. You can take it up with the dean if you want, but that's not the kind of thing that the dean's ever going to overrun me on or anything like that. That's the nature of this course, and you'll see it. Okay. It's interesting to know that this math was actually created specifically for the first part of this course. Vector calculus was created largely by a guy by the name of Oliver Heaviside and another guy whose name escapes me. He's an American. I want to say his last name was Stevens. I'll remember it later. But anyways, he's got a function named after him in thermodynamics. But those two guys more or less largely created the field of vector calculus. And Heaviside is actually the guy that made Maxwell more famous, because Maxwell had put his equations in quaternion form as well as in some crazy other terms that made them really intractable for even the most educated and competent engineers and physicists. So Oliver Heaviside translated those into vector calculus and made such a good understanding of vector calculus that people could actually start using Maxwell's equations. So we will be learning that stuff. Let's see, the distance learning course, student attendance is determined by course participation as defined by the faculty. So I already told you that's basically you signing into class and signing into the Canvas page. Students are expected to complete every assignment, activity, discussion board, whatever I assign on time. I do allow late assignments, but you are going to lose points, and the number of points you lose gets larger for the later it is. So don't do that. And not all of them have like the whole semester for you to take it. Some of them you're just going to get 0 if you say we're 4 days late or 5 days late. From there on, you're not getting any credit. So that is a real possibility. So you really need to, if you miss a due date, make sure you do it immediately so that you don't lose any more points. If you miss 4 class meetings or 2 lab meetings, I have the right to withdraw you from the course. I don't want to do that, but I'm supposed to do that. So I will do my best to try to track you down and find out what's going on, but it's best if you just keep me in the loop. Notice the 21st of March is the date at which if you drop or withdrawn from the course after that date, then you will get a F no matter what. I can't do anything about it. So make sure if you decide to drop, which I very rarely recommend anyone do, but if you do decide to drop, make sure you do it before the 21st of March and make sure you go through with it, not me. Okay, because I'm not going to take the time to do that, to drop someone just every time on time. So I'd hate for you to get an F just because you didn't go through the process. this is where I told you about the week in advance stuff for tests and all that good stuff, classroom behavior. I've got some very specific electronic device policies. That's mostly for my in-class classes, though. You just know that when you're doing your face-to-face, quote unquote, respondus lockdown browser test, that's when you're not supposed to have any other electronic devices other than the one you're using to access the final. So make sure you keep up with that. Here's the inclement weather and hazardous situation statement, where it basically says, hey, TCC, if they announce that, yeah, that's what you got to pay attention to. And they asked me to specifically say, in the event of a shutdown, if that shutdown occurs during any part of my class, that class is canceled. So if the shutdown was for 12:30, but your class started at noon, then that class would still be canceled. So just keep that in mind. That's my rule. And I think that's about it. I haven't decided yet whether I'm going to have you guys turn in the last page signed. So just keep that in mind. Here's the last day to withdraw for a tuition refund, and there's the last day to withdraw without getting an F. So make sure y'all keep that in mind. Don't plagiarize. That's bad, real bad. Don't do that. Oh, also, all of my YouTube videos, they don't say anything about it, but you can click at the bottom and it will turn on closed caption. So if any of you have any needs like that, you can see the closed caption. It's not that great, especially when you're doing technical terms like we do in physics, but it's there, and feel free to take a screenshot and ask me what the heck I really said. I'll be glad to do as much help as I can. So anyways, there's my YouTube channel. Notice it's youtube.com/Billy Younger Physics Solutions. So you can check that at any time. I would like you to be a member. So like sign on and join it, if you will. That way, every time I post a new video, you'll see it. You'll get an announcement that it's posted. When the course is over, stop following me or whatever you want, that's fine. The main thing is I just wanted you to know without me having to email you. I'm not going to email everybody every time I put a new video up. Okay. That being said, all my course recordings, at least the online ones, are going to be put onto my YouTube channel, usually within 24 hours of doing it. It takes a while. I have to download and then upload, and it's just a pain in the butt. But anyways, you can find it there. There's other Canvas support and stuff like that here. These are important websites. Again, I put my YouTube channel there just for you to check out. There's other websites, stuff like that. And this is the thing where I may or may not get you to print out this sheet or even just do an electronic signature and send to me. I haven't decided yet on that. So, all right, that kills the syllabus portion of the course. So I just want to make sure everybody was on the same page with that. Now I'm going to go back to our modules, which is where everything is sort of fed to you. And I want to show you what already exists there. So there's your link thing again for Zoom meetings. This is the stuff that I think is important. You'll notice there's a Word document format of that. That's not shown though, so you won't see that there. That's what that unpublished means. You get access to this one. I've already found some typos, so I'm clearly going to make changes to it. When I make a change to it, that new one becomes the new version, the correct version, and you'll be able to tell because it'll end not with N05B, but with, let's say, N05B _ 011022 or something like that, because it'll have the date stamped into the name. There's the formula sheet I told you about. Here's the list of all the titles of the YouTube videos that I have on my page, and it's not only a list, it's a list of the title, which is fairly descriptive, and it's a link to it, so you can actually click straight on that instead of having to go to the YouTube and then search for that particular title. And here's a link again to the YouTube channel. Again, you can see it's www.youtube.com/Billy Younger Physics Solutions. All of my notes. So when I'm taking notes on the computer, I write it on this piece of paper you see next to me, or you'll see next to me. I take a screenshot of that immediately and I post it on my Google Docs. Again, like usually within the same day, but within 24 hours, definitely. And it'll have the name PHY242N05B, and then it'll end with the date, like 01102022. Okay, so that's how you'll find them. Eventually, practice tests will be available. I've already put up practice test 1, so you have access to that right now. That covers chapters 21 and 22. Okay, you can take that as many times as you want. It's only 10 questions. It's supposed to, or actually it's not even 10 questions. It's just a small number of questions that you're supposed to be able to do in like 15, 20 minutes at most. And the more times you take it, the more experience you're getting with the types of problems that are going to be on the test. So that's there. When I actually give you a test, it's going to show up here. And I've got this one showing right now, but you can't actually access it. So I will put the due date on there, which you saw on the calendar, and then make it available, at least, like I said, where you have a whole weekend before you do it. But I usually try to give you a whole week. Okay. So that'll come up there. You'll see later. We'll have a Respondus midterm, maybe some other stuff. Again, these are all not showing to you. This is where I actually put the actual test for Respondus. So you'll see that when you take your midterm, you'll have to find an area like that. That'll be published in too. What I want you to see now is week 0. This is like a refresher of all the things you're supposed to know coming out of 241. Like you should know how to deal with sig figs. You should know how to deal with scientific notation. You should understand how to do units and dimensions to like make up an equation for energy in terms of mass and speed. Right? You should be able to do that with unit analysis or dimension analysis. And remember, when I say unit analysis, I mean like newtons, kilograms, meters, seconds, stuff like that. Whereas I say dimensional analysis, I mean L for length, capital M for mass, capital T for time, and then some combinations thereof for energy and stuff like that. You should, of course, know how to add, subtract, multiply, divide, in some sense, vectors. Okay, so this is a way of showing, this is a YouTube video showing you how to use drawing to actually create or add vectors. So that's something you should know how to do already. Here's one actually subtracting vectors by drawing. Here's an example where you actually add vectors, and I call it the greatest vector addition problem because I like use every type of notation I could to cover vectors here so that you'll be familiar with each type. You know, the 480 newtons at 72 degrees is one type. I could say 13 newtons I hat plus 14 newtons J hat. That's another way. So this shows you all those different ways. I'm not going to be testing you on these things like Cartesian, cylindrical, spherical coordinates, but let me explain to you that by just knowing their existence and what their variables are, it makes this course a lot easier. So I've written about them and then made videos about them on my YouTube channel again. So I definitely recommend you go over all these things before you get started. They're usually pretty short. I think these are all on the order of 10, 15 minutes, that sort of thing. So this is all like just prerequisites I expect of you day 1. For instance, day 1 or usually day 2, depending on how long the syllabus takes, you will be doing vector calculus immediately. So literally on day 1 or day 2, you're going to be integrating vectors. That's something you're probably not familiar with, and that's okay. We're going to teach you how to do it, but just be advised that's some of the stuff we're going to do. So if you don't know these things, you're really hating it. Okay. This is week 1, so this is our week. This is January 10th to January 16th, which basically is just telling you, hey, remember the conceptual part of homework's always due on on Sunday, which would be January 16th, but the other one's going to be due January 18th for the homework problems. And I've got them marked. They should be consistent with the due dates in Canvas as well as the due dates on MyLab and Mastering, which you can get to right here. I'm going pretty fast. Anybody have any questions? I want to make sure y'all get to those. Okay. Well, like here is where I posted, actually within Canvas, I posted a first lecture from my class last semester. I leave that up there for you because you might like it, right? But later on, I'm going to put my lecture for today, and this one will be moved down here. Some of the things I like to use are these wonderful MIT charge demonstrations and demo videos and stuff like that, just so you can do some of the stuff that I'd normally do in my class, where I'm going to have all this cool equipment and I'm going to do things where I make lightning bolts shoot out of my fingers or in my fingers and out my foot and stuff like that. It's hard to do that at home, so I make sure you have access to something similar. They're a little less exciting, I think, than mine, where you literally can see lightning bolts shoot out my side of my foot and going into the ground. That's kind of cool. But these are all here for you. You don't necessarily have to use any of them, but they're all here for you. Okay. Here's me doing a lecture on charge and Coulomb's law. Here's me doing a lecture on chapter 21. I think I called it lecture 1, but I want to say this was back when I taught 3 hours straight on a day in the summer, in which case this would be an entire chapter 21 coverage. So whenever you need to go back and say, hey, I didn't understand Mr. Younger, what he did on this particular day, or what he said about this particular problem, these are mostly repeats of the same lectures I give every semester. I soup them up, change them a little bit, but they're pretty much the same thing. I just changed little bits. Here's a link to your homework. The conceptual one you can see is due January 16th. That's the Sunday. The homework one where you're solving problems, that's due January 18th. Again, as long as you get that done by 11:59 that evening, you get full credit. If you do 1 second past 11:59, then guess what? You're going to get some points knocked off. And if you go 24 hours plus 1 second later, you're going to get more points, and so on and so forth knocked off. I usually will maybe be 1 week ahead, so I will probably be making this available as I just did right then. Okay, so you now can see what's coming up in next week as well. So you can see here I covered a little of chapter 21 in my second week. That was when we were doing a really short class, so we got a longer class now. But again, these are just a bunch of videos. I'll be pairing them out. So some of these are quite old. They're from over a year ago. I probably am not even going to make these available to you anymore, especially when they have the passwords on them, because they're saying we're filling up with the memory on the Canvas system. So what you should do is every Monday come here, check out what things are up and available for you. If you can watch some of these things before we actually cover the class, you'll be in a lot better spot and you'll ask a lot better questions during class. I'm going to still do somewhat of a lecture, but I'm also it's going to be mostly hinged on me solving physics problems for you, so that you can learn how to solve them. But this does a lot of that and gets you a lot of other information. You'll see a ton of videos up there. I think I have well in excess of a couple hundred hours of videos now. So that's basically it. You've now seen where everything will be. To access those homeworks, you can just click on here and that'll take you to the MATLAB and Mastering. You're not supposed to go to the MATLAB and Mastering separately. You're supposed to go just through Canvas. Don't do it any other way. Don't try to do it any other way. It won't let you. And if you somehow hack your way into it, as I have done, then you ruin it and you end up not being able to get your grades submitted to my grade book. As it's set up right now, these grades automatically fill in my grade book, and constantly it calculates your grade based on those things. So it's a much better scenario. Here's where you can get the lockdown browser information. What's really going to happen is when I put up my midterm and my final, I'll first put up a practice midterm that will have a lockdown browser thing on it. You'll click on that and it'll walk you through the steps that you got to do before taking the midterm, where it basically has you download the software, install it. And then in the final, you're going to do it again, go back and take that practice midterm, where you don't even have to answer the question, just going through the beginning part. But that's mainly so it'll update your lockdown browser to the latest version, because sometimes if you don't have the latest version, it won't let you take the final. So that would be a problem. So you want to make sure you use that. Here's a link. If you ever just want to go there and don't necessarily want to go to a particular assignment, you want to surf around, look and see what's in there, you can use that link. This says syllabus, but it has a syllabus that I did, I think 3 years ago. I don't know why it's there, and I haven't figured out how to remove it yet. So remember, your syllabus is actually up here in useful documents and links. Okay, and the one with the latest date is the most important one. That's the correct one. The rest of the stuff, notice all these eyeballs with slice through it. That means they're not available to you. That settings doesn't have one, but that's not available to you either. And that's about it. You'll also have one for your lab, hopefully, depending on who you have for a lab course. I know my students will have a lab Canvas page. So now that I've done that, does anyone have any questions about anything? I'm going to stop sharing here. Everyone good? So those of you who came in late, yes, I've gotten answers from enough students to know that I actually had several students that could not change the time to 5:45, so we're just going to go without it. However, we do have 18 of the 19 students in here right now, so that's good. It supposedly has 19 students in this class, and we have 18 of them. But I had enough people say they couldn't move it, so we're not going to move it. And like I said, that might have helped. I might have got more students in the class, and I always wanted to do that, so I just gave it a try, even though it made me look a little bit like an unprepared idiot. But I'm okay. I like looking like an idiot. It's not a big deal. I want to do whatever it takes to make you guys comfortable, to ask questions that you might think are stupid, or to show that you don't know something that you think you might should know. That's all okay. That's what, that's what I get paid the big bucks for, is fixing that stuff. So just let me know if you have any problems, if you maybe made it through 241 because you used your scientific calculator and you had learned how to add vectors by using a scientific calculator instead of actually knowing how to use vectors. Well, now's the time that you get to show me and you get to learn actually how to do it. Okay, because that's the way we're going to do it. So just let me know if you have any problems. You can always email me. Like I said, make sure you start the email subject line with 242 space N05B. And I should get back to you within one class, one weekday. If I don't, then I ask you to text me. So make sure you guys text me if I don't answer that, or if it's something really, really urgent. And I don't mean urgent like, oh man, I forgot to do my test. Can I get you to open up? That's not urgent. That's where you screwed up. So, so if you screwed up, then you screwed up, and that's not going to be urgent. You just send me an email. But if it's something urgent, like, oh, I was supposed to be in there for that midterm right now, and I just got, in a wreck or something, that's an urgent thing. You can text me immediately on that. Okay. All right, so let's get started. So this is a textbook you should have. Again, I think everybody, actually, Nicholas Lamb, did you have this course last semester too?
I had 241 last semester.
Was it here at COA, or I mean at TCC, or somewhere else? Sorry about that.
Yes, sir. It was
Okay.
here at TCC.
Gotcha. How about there's Edward Hetty? Did you have it as well? I'm just looking for names I don't recognize. And Edward Hetty might not be able to hear, but or be able to speak, but he can definitely type it in on the chat if he wants to let me know. Yeah, everybody else, Darren Warren, I don't think I had him last semester. So if you guys had something different, let me know, and we'll see what we can do. The best bet, if you had a different textbook, is just, like I said, get the cheapest version you can. But this is a textbook we're using. It says Physics for Scientists and Engineers with Modern Physics. You can see it says the 4th edition up there. Giancoli is coming out with a 5th edition. This is a very good book. It's been used obviously for a long time because it's in its 4th edition, and they do them out. They're doing them more frequently now, but they usually do them about every 6 to 8 years. So Edward Hetty did. He took it last spring with me. Okay, gotcha. I thought your name looked familiar, but I didn't remember it from last semester, so that was throwing me off. So main thing is I want to make sure everybody has access to that. Remember, even if you don't yet have access to MATLAB and Mastering, they give you like a 1 or 2 week free period. So there's no reason for you to have not get chapter 21 homework started immediately. Even if you didn't have this, Edward, you might have some issue with your passcode still working. If that's the case, let me know, and I might be able to work something out with Pearson to make sure you're still eligible. I think you're supposed to be eligible as long as I don't change editions. Good, you already got it set up. Okay, good deal. You didn't buy another one, did you? Good. Okay, cool. So yeah, he hadn't had it for a while, but he still managed to use it. So that's good. Everything worked out as it should be. We're starting off in this chapter with electricity and magnetism. And actually, when I took this course, it was pretty much just, we were finishing off thermodynamics. Like I had the same instructor for the first semester, and he didn't get to the second law of thermodynamics. So we started off with chapter 20, or the equivalent of chapter 20. I used a different textbook, but we started off with the equivalent of chapter 20. And then when we were finished that, we went straight into electricity and magnetism. That was pretty much all we did. But back then, and for a lot of university as opposed to community college courses, they'll have a 3-semester sequence where the 3rd semester is the modern physics. So first you do special relativity, then you do quantum mechanics, then you do nuclear physics, elementary particles, and then maybe even cosmology. So this course is typically just electricity and magnetism, maybe a little bit of extra stuff, but that's about it. But in this case, we're spanning it now in 15 weeks instead of 16. So that's going to be a little bit more tough on you guys, but I think you all can do it. And we're going to do basically 21 through 31, which is all the electricity and magnetism related stuff. And then we'll jump to thermo, which is 17, 18, 19, and 20. Then we'll jump to quantum mechanics, which is 37, 38, 39. 40 is actually it as well, but we definitely don't cover 40. But I do allow you to do 41 for extra credit. And if I get bogged down, something happens, I missed due to sickness or something like that, and we get behind, then the chapters that'll be sloughed off would be some of that quantum mechanics stuff. And then I'll switch those homeworks. Instead of being pure homeworks, they'll be extra credit homework. So no matter what, we're going through that sequence of homework. So the more of those you do, the better off you'll be. All right, so the first chapter is called Electric Charge and Electric Field. And the important things I want you to know about that is there's this quantity called charge that's actually even more important in many ways than momentum and angular momentum and mechanical energy. For instance, it's important because it turns out it's never, ever, ever not conserved. In other words, unlike energy, there is instances where energy is not conserved. We learned, for instance, in the first semester of this course, you learned about non-conservative forces. Those were forces who, and you'll learn this a little bit later, but whose cross product with the del operator, it's called the curl, whose curl is zero. That's a vector calculus term. And any field of any vector field that you find that has a curl that's non-zero is a non-conservative force field. And that means that energy will be dissipated. So if you, for instance, shoot a bullet straight up in the air, if it wasn't for air resistance, then the force of gravity would be the only thing acting on it once it left the barrel of the gun. And because of that, that's a conservative force. If you calculate the curl of the gravitational force, it turns out to be zero. And that bullet would therefore go up, reach some max height, again, ignoring air resistance, and then fall back down and would hit directly where it left. And you know, if it's perfect, it would literally, and you know, the earth wasn't rotating and all that crazy stuff that could possibly screw things up, it would actually go right straight down the barrel and land at the same place, but it would enter the barrel at exactly the same speed that it left the barrel. That's what conservation of energy, of mechanical energy, says. That basically we took a certain amount of kinetic energy, 1/2 mv squared, we converted it to zero kinetic energy, but mg capital H potential energy, which happened to equal 1/2 mv squared, and then that potential energy shrunk, and returned it back to kinetic energy, which was exactly the same as the left, which was 1/2 mv squared, only this time v is going down instead of up. That's a conservative force. Now, if you include air resistance in that, then that's a force that doesn't have a curlless field to it, okay? And because of that, that's a dissipative force, and it turns out to be air resistance is dissipative. And in fact, if the bullet did come back with air resistance, it's likely going to curve all over the place. There's no chance in heck, even less chance than it did in the original case of landing actually back in the barrel. It's going to land downfield somewhere, but it'll reach the height of the rifle end with a speed less than it left at the rifle end because some of the energy had been dissipated. Okay, so energy is not necessarily conserved, and I don't just mean because relativity taught us that energy can be created to mass and mass can be created to energy. So now the thing we say is mass energy is conserved, but I'm saying no, not even that. Has certain cases where it's not conserved, and that's when dissipative forces are acting. Now the same thing with momentum. You know, momentum is not conserved. Linear momentum is not conserved unless the net force on the system is zero, and angular momentum is not conserved unless the net torque on the system is zero. So they're very special caveats, but it turns out charge is always conserved. And for a long time, we decided that the reason that is that the fundamental units of charge were the proton and the electron. And the proton electron had the same charge. And in fact, via a series of experiments, we found that charge to be 1.602 times 10 to the negative 19th coulombs. A coulomb's a very big unit, okay? Some weaker lightning strikes might only have 100 coulombs in them. So that gives you an idea of how big a Coulomb is. But an electron is a very small particle. And in fact, it seems to be dimensionless, as best we can tell. It's a elementary particle that has no physical size to it. And it seems not be made of anything else. So we think it's a fundamental particle. And that was sort of made some sense, okay? Because the fundamental particle would have the fundamental charge, which is 1.602 times 10 to the negative 19th coulombs, which in the case of the electron is negative, but in the case of the proton, it's positive. And we call that symbol just E, okay? Or that number just E, okay? The proton had the same thing, but we later discovered the proton was actually made up of stuff. Okay. It's a hadron. That means it's made up of 3 quarks, and those quarks had, orders of 2/3 and 1/3 the electron charge. So now we know there's a smaller unit, but the big deal is no matter what, charge is still conserved. So that's something about charge. Charge is something that's always going to be conserved. So when you're looking at reactions and you're trying to see what happens when, one atom takes a electron from another atom, you got to know that the total number of pluses and minuses are going to be the same after and before whatever occurs. So that's a big deal. Another thing we want to learn about charges is there seems to be 2 different types. There seems to be a positive and a negative. And it was our good friend Ben Franklin that offered that as a way of categorizing the 2 types of charge. He just called one positive and the other negative. And as luck would have it, he was exactly wrong. We had pictured basically everything going on and worked out a lot of the laws of physics about electricity and magnetism with his definition of positive and negative. And from that, we basically pretend that positive charges are leaving the positive terminal of a battery. So if you look at a AA or a AAA battery, that little nipple on top that protrudes outward, that is the positive end. And when we put that in a circuit, we imagine positive charges coming out of that. And it's not really that, but we imagine it. Positive charges coming out of that little nipple, going through the wire, going through the load, which might be a resistor or a light bulb, and then coming back in the negative side. All that science was worked out about that stuff, all with the idea that that was positive charges. And then later we finally figured out doing the Hall effect, which is really the main experiment that you can do to determine whether it's positive charges moving this way or negative charges moving this way. That's pretty much the only experiment that discerns that. And when we did it, we found out the charges that were moving were actually negative charges. So it turns out really what's more going on is here's your AA battery, here's the nipple end, here's the flat end or the end with a hole in it, maybe. That end right there actually compels the charges that are already in the wire. It compels the negative ones to move around and go back towards the positive end. That's really what happens. But we call the positive motion conventional current, and the negative charge particle motion, we call that actual current. But it turns out it's not a problem. We can still do all of electricity and magnetism pretending positive charges are moving around. As long as you don't do something equivalent to that Hall effect experiment, then you're never going to run into a problem. So that's something else neat. We had known of this charge for a long time. You can guess of certain ways. For instance, you guys have probably experienced during the winter scuffing of your feet on a carpet and then going to grab a doorknob or something metallic, you'll get shocked. That was probably one of the main ways people first started noticing electricity. And you can make something called a Leyden jar and all sorts of neat stuff like that to collect that stuff. You can take, for instance, let's say a plastic or glass mayonnaise jar, and you can melt a little hole in the sealant or in the lid of the jar, or if it's metal, you can just poke it with a nail. And then you take a little piece of copper wire that's a little bit bigger than that hole, and you bend it or shove it through that hole in the lid before you screw the lid on, and then you take it and make it into a little hook inside of the jar, and then you sort of bend the other side so it won't fall back down the hole further. And then you have basically a spectroscope, a thing that's available to measure currents or to measure charges. All you have to do then is put 2 pieces of strips of aluminum foil, little rectangular strips like this, put them over that little hook next to each other so they lay like that. Now, if you take and expose the other end of that copper wire that's now inside the lid and the lid's on the jar, if you expose that to a charge, then what'll happen is those little aluminum foil pieces of metal will try to separate because they both have the same charge. And that's a big discovery. We now realize that like charges repel. That's why they went like this, right? And in fact, the higher the charge, the higher the angle that you'll make between them. In other words, if you get a buttload of charge, you might even get the aluminum foil electroscopes to point this far apart. Okay, so like charges repel, and it turns out unlike charges attract. And you could even try to figure out, well, what makes positive charges, what makes negative charges? And again, not necessarily knowing which is which, but you know that there's differences. you can figure out slowly but surely through a series of experiments exactly what makes what. So if you take, for instance, a rubber balloon, latex balloon or whatever, or even just latex gloves that you blow up as a balloon, and then you tie it off. If you take that, and you've probably all done this before, and rub it against your hair, not mine, because this is just mostly skin and sweat and some little stubble, but but anyways, if you rub that balloon against your hair, and then take that balloon and walk over to, say, a piece of drywall, you can stick it on that piece of drywall or even on that ceiling, and it will stay there. So you've done something. It turns out what you've done is you've charged that balloon or that glove. Now, if you kept track of what things attracted to that, you can sort of use that as a basis. Let's just say, whenever I charge a balloon with hair, that's going to make a positive charge, because you're free to choose which one's positive, just like Ben Franklin was. So now you say, okay, well, let's now rub my hair on a piece of plexiglass. And now you bring that piece of plexiglass near that balloon. If it repels that balloon, then it's the opposite charge. You say, okay, well, that's negative. And you can slowly put those different interactions in a column, if you will, where which one's more likely to make something become more positively charged and which ones are more likely to make it become negatively charged. And from that, you can know by past experience exactly which operations created positive charges and which operations created negative charges. That turns out to be very related to what you learned about in chemistry as electronegativity. In other words, how fond of the electron is, for instance, hydrogen or helium or lithium or beryllium or boron or copper or oxygen or nitrogen or aluminum or silver or gold, any of those things. So once you start to get that electronegativity down pat, you've actually figured it out just from doing these experiments with balloons and various other things. So it turns out you can take a piece of fur from a rabbit skin, say, or ideally a synthetic rabbit skin, because we don't want to just kill animals for no reason, and then rub it on a piece of lucite, and it'll make a charge. And then we could rub that piece of lucite, say, on a piece of silk, and maybe that'll make a similarly charged object, or it might make the oppositely charged object. But still, the main thing is when we start doing that, when we have the positive and negative charges, we learn that like charges repel and unlike charges attract. And we have the caveat that we can see over time that charge is always conserved. So we have like some major rules here. We have like charges repel, unlike charges attract. So opposites attract is the more everyday way of saying it. And we also have that charge is always conserved. Then comes a guy by the name of Coulomb, who there is some historical debate. There seems to be a good reason to believe that Coulomb discovered this law, but there also is a very good reason to believe that Ben Franklin discovered this law. So that's another kind of neat tick for American history here. So let me start by writing out exactly what this law is. I'm going to now switch my camera to my document cam. And I'm going to hope that it's visible. It is. That's cool. So it turns out that like charges repel. Unlike charges attract. And like charges are like plus and plus are minus and minus, and unlike charges are plus and minus are minus and plus. Okay, so that also gives us what we use to demarcate what's like charges and what are unlike charges. They're given names like positive and negative. And now we say charge is conserved. And here's a big part, always conserved. Okay, which we could write as delta Q, that's the symbol we use for charge, is equal to 0. Okay, that's a way of looking at it. So we use Q or little q for charge. And I told you the unit we'll be using is the Coulomb. Okay. And now I'm going to introduce you to Coulomb's law by way of Newton's law of gravity. So Newton's law of gravity says that the force of gravity is equal to G times M1 times M2 over D squared, where the units of M1 is equal to the units of M2 is equal to the kilogram. The D has units of meters, and the F has units of newtons, which is kilogram meter per second squared. Okay. And G is equal to 6.67 times 10 to the negative 11th Newton meter squared per Coulomb squared. Okay. Now we also know something else. The force is attractive. And acts along the line connecting the centers of mass of M1 and M2. Okay. So that's what the Newton law of gravity told us. It was directly proportional to the mass, to the product of the masses, and inversely proportional to the square of the distance between them. That means if you doubled this mass, for instance, the force of gravity, say in between the Earth and the sun, and if you doubled the mass of the sun, the force of the gravitational force on the Earth by the sun would then be twice as large. If you doubled the sun's mass and the Earth's mass, then the force would be 4 times as large. If you doubled the sun's mass and tripled the Earth's mass, it would be 2 times 3 or 6 times as large. Or if you, instead of doing any of that, you just doubled the distance between them, then you would actually decrease, because it's on the bottom and that's on the top, you would decrease the force, but not by a factor of 2, but by a factor of 2 squared, which is 4. Okay. Well, Coulomb's law is very similar. Okay. Coulomb's law says that F, and I'll subscript to E for electric, is equal to K, and nobody uses this K, by the way. We're going to use it for like the first chapter, but then we're going to get rid of it. So we're going to use it for right now, just for simplicity, times Q1 times Q2 over D squared, where Q1 and Q2 have units equal to the Coulomb. D has units of the meter, and F has units of the Newton, which is a kilogram meter per second squared again. And K is equal to 8.99, which is essentially 9, times 10 to the, I'm going to double check this because I was just using a different textbook in which we use an entirely different set of units. So I want to make sure I don't screw up on this. Crap, I didn't see it here. That's the wrong K. I didn't want that K. Okay, I'm going to steal it from the book instead of the front cover of the book. 8.99 times 10 to the 11th is what I want to say, but I'm just trying to make sure. Yeah, it's 10 to the 9th. Cool. Good thing I didn't do that. 10 to the 9th. Now the unit is going to be Newton meter squared per Coulomb squared instead of per kilogram, or instead of per kilogram squared. Oh, I did that wrong over here too, didn't I? Everybody notice that? I wrote Coulomb squared like a crackhead. Okay, so it's not supposed to be that. That's supposed to be kilogram squared. Okay, so the reason why I do this parallel is to let you see that we're learning something new, but it's not that new. I mean, you did that chapter on gravity and you learned how to deal with that force in terms of vectors and stuff. But another thing is, look how much of a difference in size this is. This is a number that's like 9 billion with a B, B-I-L-L-I-O-N. That's 9 billion. Whereas this is like a decimal point followed by 10 zeros and then a 667. So you can see already that the force electric is probably on the order of 10 to the 20th times the force of gravity. And it's actually not even that good. It's actually even worse than that. Okay. That's just from dividing this number by that number, you get 10 to the 20th roughly, right? Because it'd be 10 to the 9th divided by 10 to the negative 11th, ignoring the 6 and the 7 and the 9 here. So you'd end up getting 10 to the 20th. But if you actually wanted to compare, say, the hydrogen atom, okay, then you'd say, okay, well, the hydrogen atom has a nucleus of a charge plus E, and then it's got an electron orbiting it with a charge negative E, and that distance is what we call A0, which is the Bohr radius. And we'd say, okay, the force of gravity for this case would be 6.67 times 10 to the negative 11th newtons meters squared per kilogram squared. Notice I did it right that time. Now I need the mass of the electron and the mass of the proton. The mass of the proton is 1.607 times 10 to the negative 27th kilograms. And the mass of the electron is 9.109 times 10 to the negative 31st kilograms. And then the distance between them is 0.529 times 10 to the negative 10th meters. And then that's going to be squared. And I should really double check on that Bohr radius, since that too has been something I was using recently, but with a different textbook. And let's see, unit of length. No, I don't see it there. Probably be good enough anyways. In reality, when you divide these two, that part's going to go away anyways. So I'll say right here, I'm going to say maybe. When we get to quantum mechanics, I'll look it up again, but this is just something I do every semester. And like I said, over the break, I've been using a couple different books that uses a CGS system and all that stuff. So I'm sure my constants are all whacked up. But if I do the same thing with the force due to the electric force, then I get 8.99 times 10 to the 9th newtons meters squared per Coulomb squared times 1.602. Notice I'm leaving off the signs here. Okay, 1.602 times 10 to the negative 19th coulombs. I'm just going to square that because both of them have the same charge, but they're opposite in signs, so that we know they're attractive, just like gravity is attractive. And again, it's going to be 0.529 times 10 to the negative 10th meters, and that's got to be squared. And again, I want to just say maybe. All right, we could Google that really quickly. It's just called Bohr's radius. It's kind of neat, but using completely wrong techniques, he came up with exactly the right answer that the correct techniques gave us. So what we can do now is we can say the electric force divided by the gravitational force. Now you see that that's going to cancel out completely. And what I'm going to get is 8.99 times 10 to the 9th. Ignore that units, ignore all the units now because they're all going to cancel out because they all come out in newtons. Now I'm going to be dividing that by 6.67 times 10 to the negative 11th. And now I've got the electric force, which is 1.602 times 10 to the negative 19th. That's going to be squared. And then I have 1.667, not 607, 667 times 10 to the negative 27th times 9.109 times 10 to the negative 31st like that. And that should give us our result. And hopefully you guys will pull out a calculator and verify the numbers. 8.99. 8.99 e to the 9th times 1.602 e to the negative 19th divided by parentheses 6.67 e to the negative 11 times 1.667. Let me double check that number too, since I'm being pedantic about this. 1.67, yeah, right, times 10 to the negative 27. 1.67 e to the negative 27 times 9.109 e to the negative 31. So yeah, I'm dividing by negative 19 times negative, or multiplying by negative 19 times 10 to the negative 19, which should make it really small. But notice I'm dividing by something way bigger. So this whole number is going to be ginormous. And in fact, we get 14.2 times 10 to the 57th. So in fact, the electric force is greater than the gravitational force by a factor of 10 to the 57th. Actually, it's 10 to the 58th. Because notice that was 14.2. It's my calculator's using engineering notation as opposed to scientific notation, where it just rounds to the nearest factor of 3, or power of 3. So that's a very typical problem that you're asked to do, is compare the gravitational force to the electric force for something object, some object that exists. In this case, it was the hydrogen atom. And you can see why when we're doing electricity and magnetism problems, we never take into account gravity, because it's so infinitesimally weak compared to the electric force. Any questions on that example? So the other part about this that I wanted to show you the parallel with was how the direction of this law was handled. In Newton's law of gravity, the force acts along the line connecting the center of mass of M1 and M2. Well, guess what? It does the exact same thing in the electric force. The force acts along the center of charge for Q1 and Q2. So whenever you are treating point charges, for instance, you just lay out your point charges in space, and then you draw a line connecting those two, and that force could either be attractive or repulsive, and you draw it laying parallel to that line. So for instance, if you had a plus charge here and a minus charge here, then you know the force is going to be along this line. And if you want to know, let's call this Q1 and let's call this Q2. If you want to know F on Q1 due to Q2, which I'm going to call F12, then what I'm saying is, what is the force on Q1 due to Q2? Well, they're unlike charges. And because they're unlike, does that mean they repel or they attract?
They attract.
They attract. Very good. So that means they attract. And that means each charge will be compelled to move towards the other. So when I draw it on here, that means Q1 is compelled to move this way. So I can immediately say, oh, F12 is acting that way. Okay, so that's the way we're going to do these problems, is we can use this simple mathematical algebraic formula to calculate the force. And then we use the geometry of the problem to define that line. And then we decide, well, are they unlike or are they like charges? And therefore, do they attract or repel? And then which force am I talking about? In this case, I'm talking about the force on 1, and it's due to 2. Since these two are attractive, I know Q2 is enticing Q1 to come this way. So we know the force is going to act that way along that line. That can allow us to do the sines and cosines of particular angles to find the x's and the y components of this force. Does that make sense? All right, well, it appears I already ran over class on our first night. It's 6:10. Class is supposed to be over at 6:05. I apologize, but I appreciate you guys being so polite, not telling me, but feel free to tell me in the future. I'm sorry, I just wasn't used to that coming along so quickly because it's been like, what, 2 weeks since I taught before? So yeah, I'm a goober. Anyways, I think that's a pretty good start. I would recommend you guys watching some of those YouTube videos in week 1 to see how some of the stuff we're going to do. I'm going to do an integral tomorrow. I'm going to do some vector stuff tomorrow, Wednesday. So I will see you all then. And thanks for coming and see you next time.
All right, good night.
Good night. Anybody has questions, I'll wait
Professor.
around for the last person to leave. Thank you, everybody. Sean, Georgie, anybody have any questions? All right, everything all right, Georgie? She might just have been disconnected. All right, well, I'll let you guys go. Have a good evening.